Hello, champions. Okay, so this is chapter 1 Ratio and Proportion, Indices and Logarithms, Unit 4 Logarithm. Okay, so learning objectives. After reading this unit, a student will get fundamental knowledge of logarithm and its application for solving business problems. Let us see. Unit overview. We will learn about change of basis, fundamental laws of logarithms, what is the definition of logarithm and anti-logarithms, the laws, there are three laws: logarithms of same base, quotient of two numbers, and product of two numbers. Logarithms, your spelling mistake is there. Logarithms. Okay, so the logarithm of a number to a given base is the index or the power to which the base must be raised to produce the number, that is, to make it equal to the given number. Okay, so what did we read? Let me explain. For example, in the indices topic, we have seen a power x is equals to n. So here x is an index. Also in the form of logarithm, if I write it this equation in form of log, how can I write this? Log n to the base a is equals to x. Here x is also log n to the base a. Okay, so let us read the sentence again. The logarithm of a number, suppose the number is n, to a given base, that is a, is the index, that is x, or power to which the base must be raised to produce the number, like if we write it in this form, to make it equal to the given number. Okay, so if there are three quantities indicated by, say, a, x and n, they are related as follows: a power x equals to n. So n is greater than 0 and a is also greater than 0, but a will not be equal to 1. Why? Because 1 raised to anything will be 1. Okay, so it doesn't make any sense. Okay, let's move on. So whenever you are given logs, okay, log n to the base a is equals to x. So try to write it in this form: a power x is equals to n. You will be able to solve this with this form at, at times. Okay, so what is given here? Then x is said to be the logarithm of the number n to the base a, right? So x is the logarithm. Symbolically, it can be expressed as follows. Here it is given log n to the base a equals to x. That is, the logarithm of n to the base a is x. Now we will see some illustration below. Number 1, 2 power 4 is equals to 16 can be written as log 16 to the base 2 is 4, right? 10 power 3 is 1000 can be written as log 1000 to the base 10 is 3. Okay. Third, what about 5 power minus 3? it is equals to 1 by 125. So we have log 1 by 125 to the base 5 is equals to minus 3. Next, 2 cube 8 is equals to log 8 to the base 2 is equals to 3. Okay. Let us see this conclusions or some important points to remember. The two equations a power x is equals to n and x is equals to log n to the base a are only transformations of each other and should be remembered to change one form of the relation into the other. Like I said, if you are given log n to the base a equals to x, you should be able to convert it into a power x is equals to n. And if this is given, you should be able to convert it into this log form because they are only transformations of each other. Second point, the logarithm of 1 to any base is 0. Log 1 to any base is equals to 0. Let's transform this. It becomes a power 0 is equals to 1. What does this mean? Anything raised to 0 is equals to 1. This was the property we have seen in the indices topic. Okay, that's how it becomes that log of 1 to any base is equals to 0. Okay, this is because any number raised to the power 0 is 1. Third point, the logarithm of any quantity to the same base is unity. What does it mean? Log of a to the base a is 1. Let's transform. A power 1 is equals to a. So it means log of any quantity, that is a, to the same base, that is base of a, is unity, means 1. This is because any quantity raised to the power 1 is that quantity only. After transformation, you can see a power 1 is equals to a. Okay, so illustrations. I'm going to teach you shortcut methods to directly be able to solve questions in the exam. Okay, so if log root 2 to the power a is given 1/6. Now I'm going to teach you how you should solve it in the exam. So let us transform this first. What will you get? A power 1/6 is equals to root 2. How can you transfer 1/6 to the other side? By multiplying 6. Okay, so you get a is equals to root 2 power 6, which is equals to 2 cube, which is equals to 8. Option number, like, okay, 8. We don't have any option, right? Next, second, find log of 5832 to the base 3 root 2. Okay, so log of 5832 to the base 3 root 2. Suppose it is equals to x. So we have 3 root 2 power x is equals to 5832. Correct? So now directly how to solve this question if it is asked in the exam. Okay, so on your calculator, what does this equation means? That 3 root 2 should be multiplied how many times to get 5832? So we are going to press 2 root into 3. Okay, this is the value of 3 root 2. Multiply by. And now equal to, count the number of times you are going to press equal to until you get 5832. So let's press equal to sign. 1, 2, 3, 4 and 5 plus the first time you have already calculated. So it is 6 times. So x becomes 6. Yes, the answer is correct. So in the exam you have to use your calculator, since you don't have to solve it on an answer sheet, right? Let's move on. Okay, if you want to see how it is solved in a uh, equation forms, it is already given in the text. Let's move on. Fundamental laws of logarithms. There are laws that we are going to study of logarithms. Let us see one by one with its proof. First one, logarithm of the product of two numbers. Okay, that means log of 2 into 3 is equal to the sum of logarithms of the numbers to the same base. Suppose base is a, so it means log 2 plus log 3 to the base of a. This is what is the sentence telling. In the equation form, we can write log mn to the base a is equals to log m to the base a plus log n to the base a. Okay, these are very important laws. This will help you solve the problems. Now let us try to prove how did this come. Okay, what is the proof? So what do we have? We are trying to prove log mn to the base a is equals to log m to the base a plus log n to the base a. So this first term, okay, on the right hand side, suppose it is equals to x. Okay, so we have first term becomes a power x is equals to m, and suppose this term is equals to y, so we have a power y is equals to n. Correct? Now this is m. Okay, yeah. So now we are going to multiply these two. So we get m into n is equals to a power x into a power y, right? So this is equals to, when in the indices chapter we have seen if bases are same, so power gets added. So a power x plus y, correct? So by definition, log of mn to the base a is equals to x plus y, right? Therefore, log mn to the base a is equals to log m to the base a plus log n to the base a. Okay, I hope you understood it. For example, let me explain the last part again. What do we get? What did we get? We got mn is equals to a power x plus y, right? Let me write it this on LHS side and this on right hand side. So a power x plus y is equals to mn. So when we write it in the log form, what do we write? A power x is equals to n. So log n to the base a is x. Similarly, we are going to write log mn to the base a is equals to x plus y, right? And what was x and y? X and y were this log m to the base a and log n to the base a. So substituting this again, you get this in the expanded form. I hope you understood the proof. However, you don't have to remember any proofs. You just have to remember the laws. Second law. The logarithm of the quotient of two numbers is equal to the difference of their logarithms to the same base. What does it mean? Logarithm of the quotient means the division. Suppose numbers are m divided by n is equal to the difference of their logarithms to the same base. So the base is a. So log m to the base a minus log n to the base a. This is what the words are saying in the equation form. Let us try to prove this. Okay. So again, suppose we have log m to the base a is equals to x. How can we transform it in the index form? A power x is equals to m. The second equation, log n to the base a is equals to y. That means a power y is equals to n. Now we are going to divide these two. What do you get? M divided by n is equals to a power x divided by a power y, right? So in the index chapter you have seen it is equals to a power x minus y. Okay, so what did you get? A power x minus y is equals to m divided by n. So log of m divided by n to the base a is equals to x minus y. And what is x and y? Log m to the base a and log n to the base a. I hope you understood this one as well. Okay. Let's read this part. Similarly, log 1 by n to the base a, okay, is equals to log 1 to the base a minus log n to the base a as per the second law of logarithms. So log 1, what did we learn about log 1? Okay, we have learned that log 1 is equals to 0. So what did we get? We just got minus log n to the base a. Okay. Alright, let's move on. Illustration number 1. It is to illustrate 1 divided by n. So log half is equals to log 1 minus log 2, which is equals to log 2. So log 1 is equals to 0, right? And log a to the base a is equals to 1. Okay. Alright, third law. Third law is logarithm of the number raised to the power is equal to the index of the power multiplied by the logarithm of the number to the same base. What does it mean? Again, logarithm of the number raised to the power m power n is equal to the index of the power. Index of the power means n multiplied by logarithm of the number, that is m, to the same base, the bases are same. Okay, so it means log m to the power n base a is equals to n into log m to the base a. Let us see the proof. What do we have? Log m to the base a is equals to x. So what can you transform into? A power x is equals to m. Now raising the power n on both the sides. Now on this equations you get a power xn equals to m power n. Now let us transform into log form. We have log m power n to the base a is equals to nx, and x is this log m to the base a, which is equals to n into log m to the base a. So we can take this power out of the log. Okay, simple. Illustration number 2. Find the log of 1728 to the base 2 root 3 is equals, suppose it is equals to x. Let us solve this with the help of calculator directly. Transform this equation. 2 root 3 whole power x is equals to 1728. Okay, I am not going to tell you how you can transform in the equation form, which you can see over here. Okay, how can you take that power outside the log and multiply it? I'm going to teach you how you can directly solve in the exam. So let's see. On your calculator, press 3 root into 2 equals to. This is the first time already. Now multiply and count the number of equal to until you get 1728. 1, 2, 3, 4, 5. Okay, 5 times plus the first time. So you got it for the 6 times. So that means x is equals to 6. Okay. 1b, question number 1b. We have half log 25 to the base 10. So again now we can transform, take this inside. So square root of 25 is 5 to the base 10. Okay. Okay, so alright, this is the full equation. Hold on, let me solve it again. Okay. So what do we have? We have the first equation, log 5 to the base 10, since we can take half inside the log. Then minus log 3 square means 9 to the base 10 plus log 18 to the base 10. Now the negatives get divided and the positives get multiplied. What do you mean? Log 5 divided by 9 into 18 to the base 10. Okay, so 9 ones are 9, 2s are 18. So we have log 5 into 10 to the base 10, which becomes equals to 1. Simple question. Okay, carefully you have to use all the laws. Next topic, change of base. Okay, if the logarithm of a number to any base is given, okay, then the logarithm of the same number to any other base can be determined from the following relation. The relation is given. Log m divided by m to the base a is equals to log m to the base a. Okay, so here it should be multiplication. The sign is missing over here. Okay. Hold on. Okay. The sign is missing over here. It should be multiplication. Okay. Correct. So, what is it saying? It says log m to the base a is equals to log m to the base a into log b. Okay, so this is base b. Okay, to the base a. Let me read it again. Log m to the base a is equals to log m to the base b and log b to the base a, both multiplied. So these b and b gets cancelled. So you are left with log m to the base a. Okay. Also implied that log m to the base b, this will get divided. Log m to the base a divided by log b to the base a. So how does it come? Let me show you. Expand this is multiplication. So expand it, log m divided by log b. We can write it like this. We can split the bases into division form into log b divided by log a. So cancel out log b and you get log m divided by log a, which can also be written as log m to the base a, the way I have split this one. Okay. What is the proof? So let log m to the base a is equals to x, and you have y m to the base b and z b to the base a. Then by definition we can transform them into these index form. So also a power x is equals to, since m are equal, so a power x is equals to b power y. This means a power, so b means a power z, right, to the power y. Okay, let me write it here. A power z to the power y. So this becomes equals to a power yz, right? So now these two are equal. So x is equals to y into z. So what is x? X is this log m to the base a, y is log m to the base b, and z is log b to the base a. Hence proved. Now what will happen if I put m is equals to a? We have, okay. So now in this equation given above, this is multiplication. If I put m is equals to a, let us expand. Log a to the base a is equals to log a to the base b into log b to the base a. This becomes 1, this gets cancelled, this gets cancelled. This also becomes 1. Okay, I hope you understood this. Example number 1. Change the base of into the common logarithmic base. Simple. Log 31 to the base 5 means log 31 to the base a divided by log 5 to the base a. Again, right? And a can be commonly said as a equals to 10. Okay. Example number 2. We have to prove. Okay. So when there are different bases, split the logs. So we have log 8 to the base log 3. Okay. Now I'm going to flip the denominators. What do we get? We have log 9 to the base divided by log 16 into log 4 to the base divided by log 10. Okay, all right. So here 9 becomes 3 square, right? So 3 here and 2 here outside, right? So we have log 3 gets cancelled. Now 16 becomes 4 square. That means 4 here and 2 here. So 4 log 4 gets cancelled. And what do we get? We get, okay, and this 2 also gets cancelled. So we get log 8 to the base 10. So log 8 means 2 cube. So we can write 2 here and cube outside. So we get 3 into log 2 to the base 10. I hope you understood the proof. Okay, so logarithmic tables. We are going to skip this part from the text and I'm going to teach you how you can calculate with the shortcut method calculator trick for calculating logs and anti-logs. So all these characteristics and mantissa part, negative, this long cut methods, anti-logs, we are going to skip because all these are not going to come in the exam. If you are asked value of any log, you have to approximately use this calculator trick. Okay, what is the trick? How to calculate log x to the base 10. Okay, if there is any other base, you will have to use the indices, the laws and indices laws, logs and indices laws. Okay, that I have already taught. So what is the calculator trick for log x to the base 10? So on your calculator, you're going to press x. If you are asked the value of this, so on your calculator, you're going to press step 1, press x on the calculator. Step 2, square root 15 times on your calculator. Step 3, minus 1. Step 4, divided by phone number. Okay, so now what is the phone number? You have to remember the phone number. Okay, what is the phone number? The phone number is 0.000070 274. Okay, so this is the way to find out log of x to the base 10. Okay, you have to remember the phone number until you are asked. Okay, by approximation method you can solve this. So how are you going to find out what is anti-log? What? Okay, so once we get to the topic, I'm going to tell you how you can calculate anti-log with the shortcut calculator trick. Okay, so we have already seen this part now. Relation between indices and logarithms. I've already taught you. We have seen all the proofs for multiplication, division, okay, and the power method. Example and the change of bases as well. Example 1. Let us solve this example 1. Log of 64 to the base 2 root 2. Okay. So, how are you going to solve? On your calculator, press. Okay, so let us transform this first. 2 root 2 to the power x is equals to 64. So, on your calculator, 2 root into 2 equals to into 1, 2, 3, 3 and plus 1, 4. So, x becomes 4. Correct answer. Example number 2. Okay, so now this is a proving question. Okay, change of base. So we have log BC to the base A. This is x. Okay, so this is given, right? And we are asked 1 divided by 1 plus x. Okay, so x plus 1 is equals to log of BC to the base A, and 1 can also be written as same base of same log. Similarly, y plus 1 is equals to log of CA to the base B. Okay, add log B to the base B, and z plus 1 becomes log of AB to the base C plus log of C to the base C. Right? Now 1 divided by x plus 1 becomes log. Okay, so let me just expand this again. I'll expand the x plus 1 form first. X plus 1 was log BC to the base A plus log A to the base A. What is the property? ABC to the base A, since we can multiply since this is added. Similarly, for y plus 1 it becomes log ABC to the base B, and z plus 1 it becomes log of ABC to the base C. Okay, so we have 1 divided by log ABC to the base A plus 1 divided by log ABC to the base B plus 1 divided by log ABC to the base C. Now change of base, so divide by logs, correct, and flip the equation, and when you add these three, you can multiply A into B into C. So we get same numerator and denominator, which becomes equals to 1. I hope you are able to imagine this more than trying to solve every step in the exam. So for example, in the exam, if these equations are given and you are asked what is the value of 1 divided by 1 plus x plus 1 divided by 1 plus y plus 1 divided by 1 plus z. So you should be able to solve it as quickly as possible. Okay, next example. Again, there is a proof. Let's solve this one. So we have log 12 divided by log 24. Okay, this is A. So we are trying to solve A into B into C. Okay, so what this is A into what is B? log 24 divided by log 36 into log 36 divided by log 48 plus 1. Let's cancel the common logs. So since we have log 48 in the base, we can write 1 as log 48 divided by 48 now. So what do we have? We got log 12 to the base 48 plus log 48 to the base 48. Now we can multiply. Log 12 into 48 is equals to the base 48. So 12 into 48 on your calci. It is 576. Okay, let me clear this. You got log 576 to the base 48. So 576 is the square root of which number? 24. So 2 log 24 to the base 48. So how can you write in terms of B and C since you have to prove 2BC? So we have 2 already. Okay. 2 into what is B? Log 24 divided by log 36. And C? Log 36 divided by log 48. And both of them are equal to this. Hence proved. I hope you understood example 3. Okay, so I think we missed the antilog over here. Let me just, yes, antilogs. You can, how do you calculate antilogs? So what is antilog? For example, if log n to the base a is x, right? Then n is the antilog of x. In the indices form, we can write a power x is equals to n. So n becomes the antilog of x and x becomes the log of n to the base a. So how can you calculate as a shortcut trick? So shortcut trick for log of n to the base log of n to the base 10. Okay, shortcut trick is step 1. Multiplied by phone number. Step 2. Plus 1. Step 3. Multiply equals to 15 times. What is the phone number? 0.000070274. It is just the opposite of how you calculated log. So that you should not be referring log tables in the exam. In any case, you are asked the value of logs or antilogs to the base 10. Okay, let us summarize this unit and we can proceed with solving exercise for this unit in part 2. Okay, so summary is we have seen 3 laws of logarithms. Log mn means log m plus log n. Log m divided by n is log m minus log n. And log m power n is n into log n. So log a to the base a becomes 1 and log 1 to any base becomes 0. Now change of bases means log a to the base b. You can split it like this. into log b to the base a, and everything gets cancelled, which becomes equals to 1. Similarly, log a to the base b and log b to the base c, so b gets cancelled, you get log a to the base c, correct? This is how you can expand. Log a to the base b means log a divided by log b, okay? Or else you can also write it as inverse of 1 divided by log b to the base a, okay? Inverse logarithm property. So in a complicated way, you can obviously write a power log x to the base a is equals to x. Sometimes you can get this type of form in the question paper. The next is the two equations ax is equals to n and x is log an, the spaces are missing, are only transformations of each other, like we have seen. Here ax, it is not a into x, it is a power x, okay? Spellings are, okay, the spaces and the powers are not given. A power x is equals to n, so log of n to the base a, this is log of n to the base a is equals to x, are transformations of each other and should be remembered to change one form of the relation into the other, okay? Log of a to the base a becomes 1. If base is understood, it means it is always generally taken as base 10, for which I have shown you the shortcut formula. Thus, log 10 will be 1 since we will assume base as 10 if nothing is given, right? And log of 1 becomes 0 always. Logarithm using base 10 is called common logarithms, okay? And logarithms using base e is called natural logarithms. E means exponential number. E is 2.33. So there is one more shortcut formula in case you are asked log to the base e, the value of log to the base e, since we have seen log to the base 10 shortcut. Let me quickly also give you the shortcut formula for log n to the base e, okay? So what does it mean? This is e means exponential power, okay? So step 1, n, press step 1, press n on the calculator. Step 2, square root 12 times. Step 3, minus 1. And step 4, phone number 2. What is phone number 2 here? It is equals to 0.00024417206. Okay. And what will be the anti-log of this? This is more of e power, means exponential power is the exponential number, that means for continuous compounding. So for anti-log you can write, let me clear this, we have log of n to the base e is equals to I. So that means e power I is equals to n. So step 1 is I into phone number 2. Okay. Step 2 plus 1. Step 3 multiply equals to 12 times. Okay. So what is phone number 2? 0.00024417206. Okay. So we will continue the exercise 1D in the next part. Thank you.